the Agile Brand.
Welcome to One Amazing Thing About Classiq. I'm your host, Greg Kihlström, and I'd like to welcome Erik Garcell, Head of Technical Marketing at Classiq. He's going to be sharing one amazing thing about Classiq with us today. Classiq is the leading quantum computing software company. Tailored to all levels of developer proficiency, Classiq aims to democratize access to quantum computing with software that equips customers to take full advantage of the quantum computing revolution. Erik, welcome to the show.
Thanks for having me, Greg.
Yeah, looking forward to seeing some stuff here today. So why don't we get started, though, with you giving a little background on you and your role at Classiq?
Yeah, like you introduced me, I'm the head of technical marketing. Get to do everything I ever wanted to do with my physics PhD, which is talk about how cool physics is.
Awesome.
Yeah, so I go out and I try to help people understand what quantum computing is, what it's capable of, and how to take advantage of it.
That's great. That's great. So we're going to look at something in a second here, but first, we wanted to just have you explain, what's the feature of the product that you're going to showcase today? Who's the audience? Why is it important to them? Give us a little background here.
Yeah. So, right, Classiq, like you said, is we're a software development platform for quantum computers. We have this product called Classiq, and the thing I'm going to show you is our modeling language. Right, we have the really the first high-level modeling language for quantum computers, and that means it makes it much easier for everyone to program these systems to utilize it. And I see it a little bit like the development of BASIC for classical computers.
Nice.
Right, BASIC was this language that was made out of I believe it was Dartmouth University, and it enabled and democratized classical computing. It was made to be a programming language for those who weren't supreme experts in mathematics or in kind of the programming level at the time, and it made it usable. It's what enabled the personal computer, really, right? And even Microsoft's first product was built off of BASIC.
Right. Visual
So
Basic, right? Yeah.
exactly,
I remember
exactly.
that. Yeah. I wasn't that great at it, but I remember it. Yeah.
But it's what enabled, right? These kind of programming languages are what enables the hardware. By democratizing the programming of these systems, you can actually take advantage of all the cool things these systems are capable of.
Nice. Awesome. Well, yeah, let's take a look. Why don't you share your screen and talk us through it?
Absolutely. Share my screen here. Perfect. Yeah, so I just put up a simple bit of code here where I'm preparing just a couple of integers. And actually, this isn't too terribly fun of a code, I realize. I put integers, I just put three into variables A, B, and C. And then I'm doing some maths on it, right? But let's go ahead and say, let's just take that out. I want to say prepare to integer, let's say 5 into variable A, I don't know, 1 into B, and 3 into C. And then I have this equation, A minus B times C to the power of A. And it's going to do some maths for us. But kind of the cool thing about this is that I'm not doing anything inherently quantum-y in this coding, right? I'm kind of showing the simplicity of it. So anybody who's seeing this and is programmed in quantum computing knows that to do this would be way more work than what I'm putting on screen here. But I'll just go ahead and I'll tell the system to compile out the quantum bit of code that enables that and what we're trying to do. And here we just generated a 12 qubits, 128 depth quantum circuit that does this for us. And here's all the different elements that go into that code. But again, right, this is what enables the use of quantum computing. You didn't have to go in and figure out how do I do multiplication on a quantum computer? How do I put in, these phases? How do I put in my rotation? You don't have to worry about that lower level implementation. You can be a user of quantum computing, take advantage of the capabilities of quantum computing without having to figure all this out. And if we wanted to geek out a little bit, we always could go ahead
Why don't we
and
do it a little? Yeah.
little bit.
A little bit.
I'll export out some of the lower level code just to see what we would have to have written out if we wanted to to do this by hand. So I'm opening up this chasm code here. Um, and let's see, this would have been a good 400 lines of code
Mm, yeah.
to do a math problem, right? And that's not going to be tenable for any kind of industry scale application to do a simple application. But there's more that we can do on the platform, but keeping to the one cool thing, right? Certainly, I would say having a modeling language that makes it easy to create quantum code, to deploy quantum code, is what's going to enable quantum computing for most people, right? There are experts in quantum computing. You can absolutely still use the platform, but for most people who aren't PhD physicists trying to use this and deploy it for their companies and whatnot, higher level modeling languages are what enables that. If here I'm just doing some addition stuff, but if you wanted to do like a Grover's algorithm or something like that, right? I can just go and pull in a Grover search. Here's the equation we're trying to solve for, right? A Grover search is an Oracle search for those in computer space. And here's a preloaded example here, but I wanted to just find the area of some trapezoid. A plus b over 2 times the height of the trapezoid, right, is what you're going to get your area. And I said, find me what A, B, and C can be for the area to be 10.
Mm,
So I'm just going to apply that to the code, generate it out, and it's going to go ahead and find me the quantum circuit that computes this, do all the quantum bit of it, compile an efficient quantum code too. Because there's a lot of things that it does for efficiencies to make sure it can run on the hardware you want to run on, and with all the requirements of it. There's so much intricacy in quantum, but we can open all that up in general if we
yeah.
wanted to. But for
So
brevity,
I get,
just
yeah.
make
So along those lines, then, what would be a logical next step? So
yeah, yeah.
doing this, like, what would you do with something like this?
Yeah, something like this is what enables people to take kind of that next step in quantum. A lot of people have investigated quantum already in different, areas. If you're interested in quantum, you've already been looking into it,
Yeah.
right? But kind of, I give workshops at universities. I give tutorials to enterprise clients, and most people they've built a quantum circuit that does 5 qubits, right? They're using 5 bits essentially, the analog for a classical computer. That's not a lot of power, right? You're not going to build anything large or cool on 5 bits.
Yeah.
Same thing for qubits, quantum bits. So this is what enables you to deploy larger programs to really explore the breadth and scope of quantum computing, not just these smaller toy models, but really take this and build a pilot for your enterprise application, so you can deploy and see how it would actually operate for your enterprise or for the project you want to. Yeah.
Yeah. That's great. Well, yeah, Erik, thanks so much for joining. One last question before we wrap up
Yeah.
here.
Before.
For those that saw this, want to learn more, want to get their hands on the product, what's the best way for them to get their hands on it themselves?
My gosh, yeah. So you can absolutely go to classiq.io if you go to our homepage. Let me just go here. So classiq.io. You can go ahead and click Get Started. That's going to take you to the platform page. There's a sign up button. If you're using it for non-enterprise purposes, it's free. If you want to use it for enterprise purposes, go ahead and go to that Contact Us button over here. Let's talk and let's talk.
Wonderful. Well, again, I'd like to thank Erik Garcell, Head of Technical Marketing at Classiq, for joining the show. You can learn more about Erik and Classiq by following the links in the show notes.
Thanks for having me, Greg.
Yeah, thanks so much.